Hello and welcome to another video about correlation. We're going to start by looking at other cases with R. You remember the basketball, Boston Celtics players, point per game, etc. Here you go. Here's a chart, and out of the data you figured out that you got 0.465. Is there a linear correlation? I would say no. If you really want to, you can say there's a weak positive linear correlation. That would mean that being taller hardly relates, perhaps a little bit, to scoring more points per game in the Boston Celtics. A different case would be this one here, where we're measuring measuring the levels of an enzyme in the system of a patient that has dementia. And if the level of dementia is low, they have less of that enzyme. If the level of dementia is high, they have more of that enzyme. The correlation here will be 0.979. That's a strong positive linear correlation. So, how relevant is this R thing? I just have to do one more example just to show you how important this is. This is straight out from a famous study of 1997. Here you have the details of the study. You can go online and read it. And it's important. It's an important study. It's a bit old, 1997. And they were trying to measure out whether playing video games was bad for kids. A lot of parents were very worried about this. So they went out there and started measuring, like, how many hours a week does this child play video games. And what, how's his school performance? Does he have a lot of friends, etc., and so on? So they made this massive study looking at a lot of very different kids to try to figure out whether there was a relationship between playing video games and doing well or doing bad in school. And this is what happened. These are the actual results. I just copy-pasted this from the actual study. And what you find out is that the correlation is extremely close to zero. Think that it's 0.07, minus 0.12, minus 0.01. It means it's really close to zero, therefore there is no correlation at all. There's just no relationship. So let's look at the importance of correlation, and one important point that must be made. We can calculate whether changes in one variable affect the other. Like, is there a relationship or not? And correlation will tell us whether there is a relationship between the two variables, but it's not going to tell us if one variable causes the other. It's a very common mistake to make. It's not going to do that for us. Think about this one here. The enzyme levels at the dementia level. Remember, there was a strong positive linear correlation. But here's a question. Is it that if you have dementia, this enzyme kicks in and you have high levels of the enzyme because you have dementia? Or is it the other way around? Is it the high levels of the enzyme that causes dementia? Well, here's the thing. R is not going to do that for us. It's not going to tell us what causes what. It's simply going to tell us whether there is a relationship. And that's what R does. There are other statistical tools to figure out the relationship, but R is not one of them. It tells us whether there is a relationship or not what causes what. Now let's look at some exam exercises, some ideas of what exam exercise might look like. So here you have one. There are 4 graphs, and it tells us, hey, which scatter diagram is related with which R. Now, I like to think first. Let's look at this one here. Obviously, this is a strong negative linear correlation. Look at how it is. So we can relate to this one quickly. This is a strong positive linear correlation. There you go. And this one's here, well, this one is obviously the one that's more scattered, the one that's more clouded. This must be the one that's closer to zero. And this one is, somewhere in between, perhaps a little bit on the positive side. Hence, it's this value here. And finally, another one here, another example. They ask, they give us this very, 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 very long exercise. Like, it tells us a story about Carl and his shoes and whatever, and he starts measuring stuff. And this could be like a 7-point or 6-point question in the IB exam. So it gives us this list of shoes and days of use, and it asks us, find the correlation coefficient between the two variables, interpret the value of R, and what conclusion do you think Carl should reach? So you just go to your calculator, you're going to tap in the values. I think I already did to save us some time. Yes, here they are. And what do you do once you have the values tapped in? Well, you just go to Stat, Calc, linreg ax plus b, and you calculate it, and that's all you do. Oops. Okay, there you go. So I'm going to get R to be minus 0.03. That's a very low value of R. What does it mean? Well, it's going to mean that there is no linear correlation between the price and the days of use. There's no correlation. Hence, I can't, like, the price is not related with how long the shoes will last. That sort of conclusion, to understand what R means, is what you're expected to know. Thank you very much for watching. Goodbye.